Hello world, Adam here, aka Mushroom Tech. Welcome to my Coding Particles series, episode 2. In the last episode, I showed you how to code a bouncing ball using velocity vectors. In this episode, I'm going to show you how to expand that code to create many bouncing balls. To do this, we're going to use array and object variables, which can hold many values at once. By the end of the lesson, we'll have something looking like this. To demonstrate this, I'll be using a library called P5JS to draw the graphics, along with JavaScript. However, it should be possible to follow along using pretty much any modern programming language that is capable of drawing circles to the screen. Let's get started. Here's the project from last episode. I'll quickly recap. At the top of our code, which runs at the very start of the program, we create 4 variables. Position X and position Y, which hold the position of the circle, and we set them starting values each at 200. And velocity X and velocity Y, these hold the speed of the ball, both the horizontal speed and the vertical speed. We didn't assign these values on line 3 and 4. Instead, we assign the initial values inside of the P5JS setup function, which is a special function that's automatically called before the main program starts running. The reason I assigned the values on line 8 and 9 is because I wanted to use the special P5JS random command, which just isn't available yet when lines 1 to 4 are running. P5JS is only ready once the setup function is called. So lines 8 and 9 assign a random velocity for the ball anywhere between -5 and 5, both for the horizontal velocity and for the vertical velocity. Once all the lines in your setup function have been processed, the draw function starts being automatically called 60 times a second. Line 13 just clears the background, otherwise you would get a trail of the ball. Line 14, the fill command, sets the colour of any future shapes that will be drawn. Line 15 draws a circle, and you can see it draws a circle using the variables position X and position Y. The third number, which is 100, is the diameter of the circle. Lines 17 and 18 updates position X and position Y using the velocity variables. So we add the velocity X, the horizontal velocity, to our position X, and we add velocity Y, our vertical velocity, to position Y. To create the bounce effect, we then need to ask some questions, also known as conditions. On line 20, we ask if position X is less than 0, and if so, we invert the sign of the value. So velocity X times equals -1 is just like saying velocity X equals velocity X times -1. And when you multiply something by -1, if it's a positive, it becomes a negative, and if it's a negative, it becomes a positive. You flip the sign. That's a neat maths trick that's so useful in coding. And don't worry if you can't remember the formula. All you need to remember is that this trick exists, and where you can look up the answer whenever you require it. If you use it enough, you'll remember how to do it sooner or later. So line 20 asks if the ball has gone further left than the left-hand side of the canvas, and if so, it inverts the velocity. For it to have reached further left than 0, it means velocity X must have been a negative number, and when it inverts the velocity, whatever the negative number is, say it was -2, it becomes a positive number, so it becomes 2. Line 21 is the same, it's just dealing with the vertical position and the vertical velocity. So if the ball's gone off the top of the screen, then it inverts velocity Y. Instead of being a negative number, which it must have been, it becomes a positive number. Line 23 and 24 are similar, only this time we're asking if it's gone off the right hand side or the bottom of the screen. P5JS has got a special variable called width and height, and they're always set to whatever your canvas width and height are. Even if you're using a language that doesn't have such a variable, I suggest you create one, because it's much better to use a variable for the width and the height than to keep on hard coding numbers throughout your program. because at some point you might want to change the size of the canvas and then you have to go through and change every instance of that number. It's much better to assign variables for that. But in P5.js, it's already done for us. You can see the action that happens if the conditions are true on lines 23 and 24 are just the same as they are on 20 and 21. They just invert the velocity, because if position x has gone greater than the width of the screen, then velocity x must have been a positive number. So that's the code from last episode. Now we're going to expand this. I'm going to start by creating a second ball, but I'm going to do it the wrong way before I show you what I think is the right way. So I'm going to duplicate all of the variables and also the 2 lines of code that assigns the velocity. And then I need to give each of these variables a new name so they're all unique. I'm just adding a 2 after everything. And then I'm going to duplicate all of the code that draws the circle and manipulates the positions using the velocity. Again, I need to change all of these variables to the new variable name. I'm holding down the control key to get multiple cursors. And now we've got 2 balls, which is great, but now our code's almost doubled in length. And what if we wanted 3 balls, or 4 balls, or 1,000 balls? Not only is this really messy and makes your code really hard to read, at some point you might want to change the way your particles work, and then you have to change the maths for every single one of them. And you'll make bugs. So many bugs. Frustrating, annoying, hair-pulling, sleepless night bugs. There is a better way. Let me show you how. I'm creating a variable and assigning it a new array. The square brackets indicate the data type is an array. If you put nothing in the square brackets, then it will be an empty array, but I'm going to add some data into the array as I initialize it. For my demonstration, I'm adding strings, which is text, indicated by the speech marks. Arrays can hold any type of data that a single variable can hold, including numbers, strings, and even other arrays. I'm now showing you how to access the values by printing them to the console at the bottom of the screen. You can see I'm using square brackets again. This is to access the individual values at each index of the array. The index is an address. You can think of them being like house numbers in a street. In JavaScript, array indexes start from 0. So you can see by putting a 0 inside the square brackets, my program has printed dog to the console. If I change it to 1, it prints cat. 2, and it prints mouse. And if I change it to 3, it says undefined in the console. This is because the array only contains 3 items, which starts counting from 0. So index 3 is out of bounds. In JavaScript, you can add new items into the end of the array using the push command. Now accessing index 3 is allowed because the array contains 4 items. We can also print the entire array to the console quickly to see what it contains. This is useful for debugging your code. Now I'm going to show you how to make a loop that counts through each index of the array. Don't worry if this seems complicated. The only important thing to remember is the idea of how loops work. You can always look up the code required to make a loop, until one day you'll remember it by heart. When you initialize a loop, you can set 3 parameters. The first allows you to create a variable that will be used in the loop and assign it an initial value. The second is a condition that will keep the loop executing as long as it is true. In this case, my condition is whilst I is less than the array length. My current array length is 4 as it contains 4 items. If I is 0, 1, 2 or 3, then the loop will continue executing. However, once I becomes 4, the loop will stop executing. The final parameter allows you to make a change each iteration of the loop. In my code, I increases by 1 each iteration. This is performed at the end of each loop, so on the first iteration I will be 0. Inside the curly braces of my loop, I've got just one line of code that you're already familiar with. The only difference from how I printed the array items before is that I'm using variable I instead of a fixed number. There are shortcuts to make loops require less initialization code, but I wanted to show you how they work rather than show you the quickest way of typing them. I'll show you some shortcuts later. Back to our project. So to create multiple balls, we could convert each of these 4 variables into arrays, and that would work fine for this small project. However, as we make more complicated particle systems, where each particle has more properties, and especially if we need to be able to delete particles, we'd find that using many separate arrays leads to unnecessarily complicated and harder to maintain code. We could use an array of arrays, where each inner array contains all the properties of our particles. This is a perfectly valid technique, but there is another way to pack lots of information into a single array index that makes your code much easier to read. I'll show you that technique now. I'm going to create a new function called addBall. In here I'm going to create a new variable called ball. These curly braces indicate that this new variable is an object. Objects are a bit like a box, they allow you to pack things inside of it. So I'm going to say ball.x equals, and this is where we're going to decide how far across it is. For now I'm just going to say it's width divided by 2, so it'll start in the middle of our canvas. I'm going to do the same thing with a y, equals height divided by 2, so it starts halfway down. I'm also going to add a velocity x, and I'm going to give it a random velocity, just like I did previously in our setup function. So I'm going to make this -5 and 5 for the horizontal velocity, and I'm going to do the same thing for velocity y. So that's all the properties that we had before on our previous ball. In the future we could add some other things, which I'll show you later. And I'm going to add the ball into the particles array, which I'm going to do with particles.push ball. What this does is this ball object that we've created gets put into the array. It doesn't actually make a copy of the ball object. Instead it passes a reference to the object into the array. So if you modified ball x after putting the ball into the array and then checked the x property of the version inside the array, you would find that it's been modified there too. It can actually be quite difficult to copy an object, but it is very easy to pass a reference to it. You can have as many references to one object as you'd like. This behavior is the same for arrays too. It's called passing by reference, whereas when you make one number variable equal another, that's passing by value. So this actual object that we created here on line 27 and then filled with contents on these lines, is put into the array. Now when this function ends, this variable called ball that we created actually gets destroyed, because when you create a variable inside of a function, it's a temporary variable that only lasts as long as the function is running, and as soon as the function gets to the end, once you're past there, it gets destroyed. However, the contents of the ball that we've created, the ball object, has already been put into our array called particles, so it doesn't get lost. Now to actually make a new ball, I'm going to use a setup function. And in here we can just say add ball, and it will call our function below, create a new ball and push it into our particles array. But I don't just want to make one ball, I actually want to make lots of balls. So I'm going to create a loop, just like I showed you before. I'm going to say for let I equal 0, whilst I is less than, let's say 20 balls for now. And then I'm going to say I plus equals 1. So it increments by 1 each time. I'm just going to move our add ball function call into our loop, so that this add ball function will get called 20 times inside of this loop. Okay, now for drawing our balls and updating the balls. So in the draw function, I want to loop through every single one of these particles. There's a number of ways of doing this, but for now I'm going to show you the technique I previously showed you. So I'm going to say for let I equal 0, whilst I is less than particles dot length, which is the size of the array. I'm going to say I plus equals 1. Okay, so now I is going to count from 0 up until whatever size our particles array is, which based on what we've done at the start, our particles array is 20, and therefore this will start off at 0 and it'll count one by one up until 19, and once it gets to 20 it will break out of the loop because I will be greater than or equal to particles.length. So in here we could just move pretty much all of our code. We obviously need to modify it slightly. We could just put it all inside of this loop. However, to keep things neat and easier to read, I'm actually going to create some new functions to handle the drawing and to handle the update of the position. So I'm going to start with the drawing. I'm going to say function draw ball. Okay, and then in here I'm just going to call draw ball. But we need to pass it a copy of our ball. We need to let it know how to access the ball that we've packed into our array. So one way we can do that is I'm just going to do it right here in the loop. I'm going to say particles in square brackets I. So that will be the current array index of our particles array that which we're iterating through. When we do that, it actually passes a reference to the ball object, which is inside of our particles array at that index. So in our draw ball function, we could receive a parameter, and the parameter we want to receive is ball, which we're actually passing to our draw ball function from here. So now what we can do is we can just copy our drawing code. I'm just going to paste it into our draw ball function. And we need to modify this slightly. So we can just say circle ball.x and ball.y. Now I should point out that this variable called ball is being created right here. It's not actually the same variable as this ball here, but it is the same object. So we created this object and we packed it into the array, and then we fetched it out of the array, passed it to this function. As we pass it into the function itself creates a new variable and assigns what was passed to it to this new variable called ball. So now we need to handle the updating as well. Now the updating could happen before you draw the ball or afterwards. Previously I've done it afterwards, so I'm going to stick with that for now. I'm just going to say update ball, and I'm just going to do the same thing. So we're just going to pass it a reference to the ball. Okay, now we need to make our update ball function. So I'm just going to create the new function here, update ball. Again, I'm going to set a variable which receives the information that's passed to it when we call it from here. I'm going to call this variable ball again. I'm just going to grab all of this code that we worked out before. I'm going to paste it into the function. So we've got ball.x plus equals ball.velocityx, and we've got ball.y plus equals ball.velocityy. So these variables here, they're known as properties when they're inside of an object, but they're really just like a variable that's part of that packed object. Well, they were created down here. So we added an x, a y, a velocity x and a velocity y into this object that we created here, which we packed into the array. And therefore we're able to access them here too, as we unpack them from the array. So now we just need to handle the bounce. So again, we can just say if ball.x is less than 0, then we flip it, and on the lower down one here, if ball.x is greater than the width, then we flip it. And just do the same with the y. If ball.y is less than 0, we flip the velocity, and if ball.y is greater than the height, we flip the velocity. And now we just need to add our variable called ball to access the velocity properties. Okay, and that should actually work. Wow, look at that. Look how many balls we got now. That's a tiny bit more code than we had before, but not massively more code. And now we've got 20 balls. Just like that. Now imagine if we want 500 balls. The amazing thing about coding this way is all we need to do when we go to our loop in our setup function where we create all the balls is if instead of having 20 here, we change this to say 500. Now we've got 500 balls. Wow, they're a bit big. I'm just going to shrink them a little bit. So when we draw the ball, currently we've got 100. I'm just going to change this to 20. And now we've got some much smaller balls. A really neat thing about using objects in this way is if we want to add new properties for our particles, it's so easy to do. For example, let's create a new size for our ball. At the moment we've fixed our size here, we're just hard coding the number 20 in our draw ball function. So what we could do is when we add a ball, we could add a new property to our ball object. We could say ball.size equals, let's say random, and let's say anywhere between 5 and let's say 20. So our ball object now gets packed with a size parameter. And we can fetch it from our draw ball function very easily. Here we got ball.x, ball.y. We can just say ball.size, and we should now get lots of balls of different sizes. Nice. We could do the same thing with a color, for example. So we could say ball.color equals, now because we're working in P5.js, the easiest way to store a color is to use the P5.js color function, which can create a color and store it for later. So I'm going to say color, which is a function that we call, and I want to create a random color, and we could do that by saying random brackets 255, and that will create a number between 0 and 255. Oops. So I also need to update the color here. So when we go to draw the ball, at the moment we've got fill magenta. Instead we could say ball.color. And now we've got lots of grey balls. If we wanted them to be colorful balls, we could go down to where we created our color, and using P5.js, when you use their color object or any of their functions that receive colors such as background or fill, then if we pass it one number, we get a grayscale, 0 being black and 255 being white, and anything in between being some kind of gray. But if we pass it 3 numbers, then we produce an RGB color. So how much red, green and blue there is. So I'm just going to copy this random 255 function call that we used to create a number between 0 and 255. I'm just going to paste it in 2 more times. So if we run it now, we should get rainbow balls. Mission accomplished. We've now created lots of balls using a very manageable technique. So just one more thing I'm going to show you to make it more like the original demonstration. When we go up to our background command, which is a P5.js way of clearing the canvas, we're just filling the canvas with black every single frame. If we didn't do that, in fact I'll just show you, if we turn off the background command altogether and we run this, we'll see it gets pretty crazy. Nice. But what we could also do, that I think looks really nice, is if we pass it 2 numbers. So previously I showed you 1 number creates a grayscale, anywhere between black and white. 3 numbers creates an RGB color, how much red, green and blue there is. If we just use 2 numbers, the second number is what's known as the alpha, which is the transparency, or how much that color should be applied when it's used. So here, if we typed in 255, it will just carry on working exactly the same, because we're applying a black, and the black is completely opaque. It's completely covering up everything that was below it. But if we lower this number, I'm going to lower it down to say 100, then every time it adds the black, it actually adds only some black. So what was behind it is still somewhat visible, and we can see we're now creating trails. And as this number gets lower, let's take it down to 10, our trails get longer and longer. It takes longer and longer to fully clear the canvas at any individual point. And if I took this all the way down to 1, it's going to be much more like it was when I just turned off this command altogether. That's a bit hectic, a few too many balls there to see what's going on. I'm just going to lower this down to 20. And you can see we've got these trails. They are slowly fading, but really, really slowly fading. So I think maybe 1 is a bit too low for this effect. I'm going to put it at 10. I think that works really well. Almost at the end. I've got just one final thing to show you. I promise you some shortcuts to make it easier to loop through the arrays. There's one small thing that we can do on this loop, though it's really subtle. It's only going to save us just 1 character. But I personally prefer the way it looks. As we increment our variable I by 1 each time, we can instead use I++, which just means increment by 1. If we needed to change the amount by 2 or 3, that wouldn't work. But yeah, I++, it works in JavaScript, some other languages, not Python. You can have it either with a space ++, or I prefer it to have the ++ straight after your variable name. And that trick can work anywhere in your code, not just when you're setting up loops. I don't know of any other tricks to speed up that loop that counts the number of balls that need to be created, at least ones that won't make your code more confusing. But there's something much better we can do for the loops that iterate through arrays. So I'm going to show you 3 tricks. The first is that I think it's often much better to create a variable of the object inside your array rather than keep on accessing the array directly. It just makes the code a little bit clearer to understand on each line. It doesn't make much of a difference here in this small example code, but sometimes you need to access the items inside the array over and over, and typing all those square brackets gets annoying. Because we're looping through an array where the length is known, JavaScript has got a shortcut to count the number of items in the array. Let I in particles. This does exactly what our loop was doing just now. It iterates 1 by 1 up until the array length. This can be very useful if you need to index for some reason. For example, if you're working with multiple arrays with matched indexes. But for our example here, we can go a step further. Change in to of, and instead of iterating through the indexes of the array, it iterates through the values of the array, which skips that step I showed you where you assign the value of that array index to a variable. I used a shortcut where it assigns either the index or the value to a variable using in or of pretty much every time in my code. But I wanted to show you the other way so you understand what's actually happening. And I do have a big warning for you if you're going to use these shortcuts. It's so easy to get confused between using in and of. And so often you won't get any kind of error message. Your code just won't work how you're expecting it to work. So do watch out for this. And this concludes episode 2 of my Making Particles series. In the next episode, I'll show you how to make fireworks in order to learn about gravity. Thank you for watching. Happy coding.